Here we go. Okay, so we did a keypad lock. We call it Keypad Lock 2.0. There isn't a first one. We just make sure that this one's very advanced. And what it is there's three components. There's a speaker, which is for the tone, so you can actually play it. And then the tones on here as the characters, they sound like what you would hear on a standard American telephone, which none of our cell phones use it anymore, but it's kind of cool. And then we used a keypad, which we got from Mr. Burse. And then we have a lock in there, and the lock is what makes this thing sing. And so that's what we have for it, and then we have a library that's in the code in the library, so we can take tones and we can match those tones with the hertz of all these different notes that we want to put together, and those will make a melody.
Okay, so for our demonstration, who wants to be a volunteer? Perfect, come right up. Sounds good. Okay, you can just stand right up here. Now you're gonna enter the secret passcode, okay? It's 1, 2, 3, 4, okay? You got that? And then hit the star. Okay, take your prize. Have some. Merry Christmas. That's all.
Oh, that was awesome.
Yep. Any questions?
Can you show us how secure it is? Like, what if they put the wrong code in?
Well, you see, first off, this project relies a lot on trust. I mean, plastic isn't the best material, but it's the thought that counts.
It just won't let you have anything.
Yeah, so if it enters the wrong code, you can't get anything in here. It's solid.
I mean, if your hand's skinny enough, I suppose you could just go on there and reach stuff.
Can you show, I mean, maybe it's because I'm in the back, but can you show, like, what is it actually doing inside the drawer?
Okay, here, actually, I'll open
Yeah,
this up.
just open it up, yeah.
Forgot our own passcode somehow.
So,
Okay.
yeah. What
I don't
happens?
know how much we can tip this.
Yeah, you can tip it all the way.
Okay, so we have our breadboard right here, which is where it connects the locks and all the different components to it. And so we have this, sorry, I'm probably steering some of you guys this way. We'll go behind here. So we have a lock, and then we have this makeshift circle here, so that's how the lock will work on the inside. And then we have a speaker. Where's the speaker at? The speaker's hanging in here with all of our fancy wires. And then we just have the keypad right up here. And so once you type in the code, it goes, or once you type in the passcode, it goes through here and it recognizes the upload code that we actually have. That'll tell it if it's a success or a failure. And if it's successes, this will dislodge for about 5 seconds, and then it'll go back to normal, and then that allows you to keep moving it inward. So you can just reset it.
Right. So we have it carefully positioned so that if the lock goes back out after you open up the drawer, you can slide it back in there like this, and then it's locked again. So, anything else?
What physically moves that back? Like, how's that moving back and forth?
We have a power supply in here, like a second one.
Well, we have one.
That was
we
a
have
very
two.
good idea to lock this.
It's good.
Yeah, it is running on 2, actually. We should have like different brands.
So we have one power supply right here, which is just a 9-volt battery.
Yeah, that one's a 9 volt, and then the speaker we have over here, this one runs on 12 volts.
Right. Which, because it wouldn't really be that, I don't know, economical to put about, I don't know, 4 batteries in here just to power a lock.
I guess I didn't mean like the actual electricity. I meant like, is there a motor? Like, how is that moving in there?
Okay, so it's a magnet, I believe, so that when you turn on the, or when the Arduino tells it to go on, this magnet kind of powers on and pulls the physical lock in, and then when it says to go off, it just releases, the magnet turns off, and it just flows out.
How is this product going to revolutionize America?
Good question, I'm glad you asked.
People are getting their money stolen often in America by banks, and so we can use these.
Right.
Political statement.
Next question.
This isn't so much as a question, but I noticed, and I liked how you had the Zelda music in there.
Yeah,
A
I
lot.
saw that. Good.
Are there any other questions?
Yeah, this is more of a comment. I don't know if the rest of high school students realize this or not, but their code, if you listen, you can hear it's actually like the tone that it's playing. That is the exact tone that it plays on a telephone, right? Like a touch tone pad.
Yeah.
Yeah.
And they spent a lot of time and a lot of frustration over trying to figure out how to do that. Because the way that it works by default is that speaker can play one pitch at a time. But if you listen carefully, you can actually hear it. Theirs is actually playing 2 pitches, and it's kind of, we learned about it through doing this project, that the way that a touchtone pad works. Can you explain that?
Yep.
You want me to explain it?
Yeah.
Okay.
Go for it.
Okay, so the tone will play 2 tones at a time. And so when you click this, it's really playing 2 and it comprises as one and it makes the American telephone sound. And so when it goes through here, it'll read off like digits in our code as variables. And so then you can characterize those to certain mixes of tones that you can use. And so then you can play musical instruments like that. That was actually backwards. Would you like to do it, Bobby? What? You want to play a song?
And it's like every row has the same low tone, and every column.
Yeah, every row
has
has the
high
same
tone.
second tone that we're using, and then every column, has the same first one.
So it's like almost it's a matrix kind of thing.
Yep.
Yeah.
All right, any other questions? Okay, so we definitely will have time at the end so people can come around and try to remember that secret code and see if they can hack it into the system.
I don't believe you guys. Okay.
All right, thank you.
Thank you.